So for problem number 1, in part A, we're asked to find the changing range with an exact number, meaning an increment. For the increment, we need to use the formula of delta y equals y2 minus y1. This means that we're using the same formula we have twice, subtracting one from the other, inputting the x1 and x2 values. We know that in our equation, the x will go in the theta because it's a variable that we have. The other variable, velocity, is a value of 2500. So the first thing we need to do is change the angles in degrees to radians due to the fact that we have a trigonometric function with a theta in the equation. After doing this, we input the values from the formula. So we input first the x2 value, which is 11 over 180 pi rads here, and then the second, which is 1 over 18 pi rads. We then input the equation in the calculator to get the increment. So here's where we get that the change in R, standing for range, is 6,364.541033.
In the second part of the problem, we're asked to do the rate of change by differential. This means the approximation. We have the same formula, which we only need to derivate when doing differential. We have the same values, x1, x2, our dx, there is the x2 minus x1, that gives us pi over 180 rads, and our same constant, and theta, that becomes our x1 when doing differentials. Here all our variables, we just substitute with our values. There is 2500, pi over 18, and our dx, and plugging this in the calculator, it gives us an answer of 6507.4679.
By analyzing the context of the situation, we realized that by only one difference in the angle of elevation, the range in the projectile can change a lot. This means that in any real-life situation, even though the change seems a little bit different, it will be a lot of difference once that you plug it in and see the actual result.
For the fourth part of this problem, we know that we need for the increment in the situations, we need precise numbers and in short numbers, and the differentials where we don't need precise numbers in a real life situation.
Okay, for number 13, we have the integration of 12 over x cubed multiplying 5 minus 3 over x squared to the 5th power dx. And then using substitution rules, we take out our u, which is our term with the highest power. Our u is x minus 3x to the negative 2. And then that we differentiate that and we get 6x to the negative 3 dx. And then we solve for the x. And then you rewrite your formula with the new terms, and then we're able to cancel 12, 6, and x3, and x to the negative 3, and we're left with 6 u to the 5th power over 3 du, and we are able to cancel these. We get 2 u to the 6th power, and then you put your u value here, and this is your answer.
Okay, first of all, you have to put this to the top, and it will give you 6 to the x to the negative 1/2, and then you have to expand this one. You can then do the distributive property, and this will give you 9x to the 4 minus 6x to the 5 over 2 plus x, and then here you do distributive property, and that will give you 54x 7 over 2 minus 36 x to the 4 over 2 plus 6 to the 1/2.
So next we're going to integrate this. First of all, the trick that showed us the teacher is to add up the numerator plus the denominator and then flip it and multiply it times a constant. So here what we'll do is basically multiply 54 times 2 over 9 and x to the 9/2. This, when you simplify it, it gives us a 12. So it's 12 x to the 9th power square root. Here's the 2. Now this one, 4 over 2 simplified is x squared. So here it's the direct way of integrating is x, it's n plus 1, so x cubed over n plus 1, which is 3, 6. So simplified, we have a 12. We keep the sign, so it's 12 x cubed. Now here, 6x, sorry. It's the same case of here. So 1 plus 2 is 3. So 3/2. And then you flip it and it's 6 multiplied times 2 over 3. This gives us 12 over 3, which is a 4. So we keep the sign, plus 4 x to the 3/2. So this is our final answer. The correct way to write it is like this: S f of x dx. So our answer is 12 square root of x to the 9th power minus 12x cubed plus 4 square root of x cubed plus c.